Find the interval on which the graph of function is concave upward if the function is this. So you, first of all, you have to know what is concave upward or concave downward. So it means that the function is looking like something like that. So this is upward, concave. And if it looks like this, well, it could be like this as well. This is concave downward. But for concave upward and downward, we have a test. So concavity test. If f is twice differentiable on an interval AB, then we have these two things. If f prime, f double prime, sorry, the second derivative works with concavity, the first derivative works with increasing, decreasing. If f double prime is positive, then the graph of f is concave upward or concave up. If f double prime is negative, then f is concave down. So that is what we have, and we use that in these cases. So let's just then go. So to find the concavity, we need to use the above test. So we need to find f prime and f double prime. Okay, so this will take a little bit time. F prime x, this is quotient, derivative of the numerator times the denominator minus x times derivative of the denominator, and then the denominator squared. If I differentiate, what I will get is x squared, derivative of x is 1, so 1 times x squared plus 1 is x squared plus 1 minus derivative of x squared plus 1 is 2x, and then multiplied by x, it will be 2x squared. There's a negative sign there. And then the denominator is this guy. So what we find here is 1 minus x squared over x squared plus 1 squared. How about f double prime? Okay, so we will do the derivative of that guy. So 1 minus x squared prime times x squared plus 2 squared minus derivative, so the numerator itself times the derivative of the denominator. Yes. Okay, we need to simplify and make it as simple as we can. Let's complete the differentiation. Minus 2x times x squared plus 1 squared minus 1 minus x squared. The derivative of this piece is 2. You see, derivative of u to the power n is n u prime u to the power n minus 1. So here n is 2, u is x squared plus 1. 2 times u prime is 2x times u to the power 2 minus 1, which is and the denominator is that. One thing which is important here to see, and it will be, well, since we are going to work with f double prime, the simpler we make it, it will be better. So here I noticed that there is factor of x squared plus 1 in the first part and x squared plus 1 in the second part. So I factor that out and I get x squared plus 1 times minus 2x times x squared plus 1. I'll take one of these power and the other one stays there. Minus, so this will be 1 minus x squared times 4x over x squared plus 1 to the power 4. Okay, it takes a little bit time, but what you notice is that this cancels with that. Also, I get minus 2x cubed minus 2x minus 4x did I? Yes. So minus 4x plus 4x cubed. And if you simplify that, so let me just write final result here. The denominator is x squared plus 1 to the power 3. Then the numerator here, 4x cubed minus 2x cubed is 2x cubed. Minus 2x minus 4x, this will be minus 6x. Okay. We found the second derivative, and now we have to determine where it is positive or where it is negative. In other words, we have to find sign table for f double prime. Sign table always starts with letting that thing to be equal to 0. Fraction of two things is equal to 0. That means that the numerator is equal to 0. From that, I need to simplify this. And this is one of the easy quadratic cases. Not quadratic, the third degree case. So I factor out 2x will be x squared minus 4 equal to 0. And from there, I get x is equal to 0, x is equal to 2, or x is equal to negative 2. Okay, f double prime has 3 roots. Let's go see what is happening. Negative 2, 0, 2, plus infinity, minus infinity. This is f double prime. At these points, this guy is 0, this guy is 0. Note that the denominator, look at the denominator. Let's just check for a second. Denominator is x squared plus 1, which never vanishes. So that means that f double prime is defined everywhere. But the important thing is that no matter what you do, the denominator is going to be 0 because x squared is positive. Plus 1 is another positive. Square or cubic, any positive number, you get positive. So the sign of f double prime will come only from the numerator. And the way it will work here, again, you just plug in different values, 3, 1, negative 1, and negative 3. Well, you do the work, but what you will notice, this is plus, this is minus, this is plus, this is minus. And now the test for the concavity says that, okay, look, the function f is concave downward here and there, and concave upward.
Yeah, so there's a small mistake with the last step, but I don't think it will affect the outcome. So it's x squared minus 3, not 4, in the brackets.
Oh, I see. Yes, yes. Yes, thank you. That's good that you notice it here. It won't change much here, but that's good that we have now the correct values. Thank you. Oops. Yes, thank you. So, well, then we know that f is concave upward or up on the interval what? Negative root 3 up to 0, and on the interval root 3 up to plus infinity. Where it is concave down, so concave downward on the interval negative infinity to negative root 3 and 0 to root 3. And this way, we find where the function is concave upward and concave downward. Let me just continue this because we have done all the work for this. This will also can be used for an example for the point of inflection. Point of inflection is a point at which the derivative, the second derivative first, the second derivative change the sign. We have to make sure that the first derivative exists, and then as f double prime is 0, and before that and after that they change some. So here in this example, x equal to new root 3, 0, and root 3 are points of inflection. And that will give us what we were looking